Hi everyone, I'm going to be presenting number 6, which is book problem number 3.8, and it says, let A and B be an R. Show that if A is less than or equal to B1 for every B1 greater than B, then A is less than or equal to B. We're going to want to prove this by contradiction. So in order to prove this by contradiction, we want to assume that A is not less than or equal to B. So we will assume that A is greater than B. If A is greater than B, then we can subtract B from both sides, where we end up with A minus B is greater than 0. From here, we can take half this interval and get C equals A minus B all over 2. And we can see that C is greater than 0. Next, we're going to add B to C. So when we add B plus C and we get our common denominator, we end up with A plus B all over 2. This is essentially the midpoint of A and B. We also know that C is greater than B, since C is greater than 0. Next, we will subtract C from A. Once getting our common denominator again, we end up with A plus B all over 2. If we gather our results, we can see that we end up with A plus B all over 2 being less than A and greater than B. Or we can even say that B plus C is less than A and greater than B, since we know that B plus C is equal to A plus B all over 2. Next, we're going to consider B1 equal to B plus C. Given that A is less than or equal to B1, we can say B1 is greater than B. And by both results, we end up with A being greater than B1 and less than B1, meaning that our assumption was wrong and we have a contradiction. So it must be true that A is less than or equal to B. Thus, we have proven that if A is less than or equal to B1 for every B1 greater than B, then A is less than or equal to B.